In this lesson, we shall look at the topics that must be known for the June examination that's oncoming. Ordinarily, the June exam is written in 2 hours and it's out of 100 marks. We're going to be looking at paper 1, but also we're going to be having a chance to look at the second paper as well during the course of our discussion. And let's get started. Right, the first question is very popular. I must indicate that this question is a question that was done before. There's a student who had a chance to have a look at that one. And now we're gonna quickly cruise through. I'm allowing the new students to learn. There are new things you're gonna see as well. Um, okay, yeah. So the equation, this one, for instance, equals k. Solve for x as k equals 0. So can you try this one, please, and give me the answer quickly? Both of you. I know that Tando has seen a greater part of these, but there are new things you're going to see, Tando. Don't stress. Don't think that everything you've seen, because, and then now you just simply let me know um, when you're done. You let me know. Right, so please, both of you get started, get cracking. I'm interested in seeing what Pekala is going to say because I've already hinted these things earlier to the other student. Pekelelo is the one who was not here. So I'm then saying Pekelelo would be the candidate to participate the most. So, and you share with me the answer when you're done. Right, you share with me the answer when you're done. Right, how far? Anyone done? Who is done? Everybody's sleeping. I hope people are not sleeping.
So
Yes.
I got x is equals to 2 or x is equals to negative 4 over 3.
Excellent stuff. Thank you so much. Because now we have this equation here, and we have exactly x minus 2, and then we have 3x plus 4 equals 0. And from these, you have x equals 2, and from these, you have x equals minus 4 over 3. You get the point. Okay, so that is what we have. And that is what you got, Pekele. Is it correct?
Yes, sir.
Good. Right. The next question is 1.2.1, and we are practicing together. Right. 1.2.1 is the square root of 2 minus x is equal to x plus 4. What do we do first here? What is the first step? What is the first step here? Right. What is the first step? Okay, you're
Sir,
yes. We square both
I'm not
sides.
sure.
Yeah.
Yeah, I'm thinking of that.
Okay,
Yeah.
good. I'm excited. Okay, because I'm trying to like keep you guys engaged a little bit, so that you can understand better. Because if you're following like this, then you're gonna understand better. But if you're sleeping, I know very well that you're not gonna understand better. So in the end, then what we're then getting is therefore what has happened here? My apologies. All right. Now, if you square both sides, then you have this. So the square removes the square root, giving us 2 minus x equals, okay, if you square this one, you square x, it becomes exactly x squared. Then x times 4 is 4x times 2, which is actually 8x. 4 squared, what is 4 squared? It's exactly 16. Right. And then now you have exactly x squared. And then we have 8x. You bring this one across, it becomes exactly a 9x. And now you have this one, which is exactly 16. 16 minus 2, which is exactly what? If 14 equals 0. If 14 equals 0. So, right, we continue to then say, we have exactly this. What are the factors of this? The factors of 14 that give 9 are exactly 7 and 2. So that x is minus 7, or x is what? Is minus 2. Now you just need to evaluate, because when you put minus 2 here, you have minus 2 plus 4, giving us a 2. Minus 2, rather 2 minus into minus 2 gives us a 4. The square root of 4 equals 2. So this one is okay. But if you put minus 7 here, you have minus 7 plus 4, giving us a minus 3. So this one is invalid, or it is inadmissible. So that in the end, the only solution is that one. So in principle, then we're saying x is not equal to minus 7 there. And obviously we've solved 1.2.1. Any question, any suggestion? Maybe you're seeing a typo and you need to then state exactly what you need to see there. Right. You need to state exactly what you're going to see there. The next thing is now you need to do like 1.2.2. In 1.2.2, you need to deal with this one here, and you need to calculate this one to correct to 1 decimal place. So what do we do here? Correct to 1 decimal place. There are a couple of things that you need to do. Obviously, once the examiner says, because this is from a junior examination, correct to 1 decimal place, you need to write 2x, x minus 3 equals 1, expand. 2x times x gives us 2x squared. 2x times minus 3 gives us minus 6x. You bring the 1 across, and this equals 0. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And then we have our minus b. Our b is minus 6 plus or minus the square root of the b squared, which is minus 6. You square that, minus 4a, which is 2. C is minus 1 all over twice a, which is 2. Like so. And so what therefore does this give us? What then does this yield? This therefore is able to yield a result as we are able to see clearly what happens over here. Which means therefore x is equal to, right, so we continue. Apologies if I lose you. If I lose you, please try to reconnect. It's all technology. Sometimes it's all networks and things, and it's beyond me. Right. So now you have the negative and negative, which becomes a plus. Plus or minus the square root of 44 divided by 4, which means x is 6 plus the square root of 44 divided by 4. X is 6 minus the square root of 44 divided by 4. Right. So continue. Right, then obviously what we then using here is the rest of this calculator. We can use a calculator to simplify this. So this one is 3 decimal comma 2, or x is approximately minus 0,2, like that. So these are the solutions to this question. Who has a question, or who has a suggestion, who has an input to make? Who is really saying, okay, but yeah, I have a contribution, or there's a mistake somewhere I'm seeing. I think we need to add a 2 there. I think we need to remove this or that. Please let us know. Please let us know. In the absence of comments, we move to the next question. Right, the next question is 1.2.3. In 1.2.3, we want to solve for x given this one. We given x squared plus 4x plus 3 divided by x minus 1 is bigger than 0. So to solve this one, we proceed as follows. Let us find the factors of this expression. Let us find the factors of this expression. Right, to factorize the top, we actually can be able to factorize with ease and be able to write x plus 1. Open brackets, x plus 3 in brackets. All divided by x minus 1 is strictly bigger than 0. So this is what we do. This is what we do. And to solve this one, we find things we call critical values. Right, the critical values are exactly x equals minus 1, x equals minus 3, x equals 1. You have x plus 1, x plus 3, x minus 1. So x minus 3, x minus 1, and x1, and this is the x-axis. And we are able to make these marks here, or these markings here. Right, at the bottom of this, you put x plus 1 and x plus 3, all divided by x minus 1. Right, so in the end, if x is less than minus 3. Pick a random number that's less than minus 3, maybe a minus 5. Minus 5 plus 1 would give us a minus 4, meaning it's going to give us a negative number. Each person can choose their own number. Okay, a number less than minus 3 can be minus 5. A minus 5 plus 3 is a minus 2, and the result is therefore negative. Any number smaller than minus 3 it's a minus 5 still. Minus 5 minus 1 is a minus 6, a negative number. So only put a sign because each one can, like, come up with their own number. So you multiply these two and divide by these. Multiply these two, get a positive. You divide by these, you have a negative. Between a negative and a negative 3 and negative 1 is negative 2. So you have negative 2 plus 1 is negative. Negative 2 plus 3 is positive. Negative 2 minus 1 is negative. And then you divide, you have a positive. Okay, because you have this one, x plus 1, the sign of the x plus 1, the x plus 3. So you multiply these, get a negative, you divide by negative, you have a plus. Between a negative 1 and a 1 is a 0. 0 plus, you can pick a 0 here, or any number. Okay, I'm going to pick a 0, or you can pick a 1/2. Well, 0.5 is between minus 1 and the 1. So I'm going to pick a 0 between a negative number and a positive. So 0 plus 1, it's a plus 1. 0 plus 3 is a plus number. 0 minus 1, it's a negative. Okay, then you multiply the sign of the x plus 1 with the x plus 3, divide by x minus 1. So you divide a plus by a negative, you have a negative. Bigger than 1, you have what? Right, bigger than 1, any number bigger than 1, maybe a 5. 5 plus 1 is a 6, positive. 5 plus 3 is an 8, positive. 5 minus 1, it's a 4, positive. If you multiply the top and divide by these, you have a positive. So in the end, then now you want to write the answer to this one. And in the grade 11 exam, to write the answer to this one, you have to take note of the fact that we're looking for where this is positive. Positive is here and positive is there. Right, so which means that the answer would be between minus 3 and minus 1, or x bigger than 1. When x is bigger than 1, you still have the positive there. When x is bigger than 1, you still have the positive there. So that is what we have. That is what we have. Right, so now we have exactly the following there. We have exactly the following. Right, so obviously at this point, to have exactly that, we look at now the method of completing the square as is what we ought to do next. The method of completing the square, we spent a lot of time discussing it with Pekhalelo and the rest of the group a couple of weeks ago. We were given 2x squared minus 3x equals 8, and want to use the method of completing the square, because solve for x, given 2x squared minus 3x equals 8 by completing the square, and want to complete the square in this expression. Right, a couple of things are at the heart of the operations. We're given 2x squared minus 3x minus 8 equals 0. This is what we have. What do we do here? To complete the square, we need to make sure that the coefficient of the quadratic term is obviously positive, or is rather a 1. So at this point, it means therefore you take 2x squared, you divide by 2, you have 3x, you divide by 2, you have minus 8, you divide by 2, and the result is clearly a 0. And this gives us exactly x squared minus 3 over 2x minus 4 equals 0. Like so. Okay, you can write like that, but yeah, you can also write it like this. Okay, you can just take it from the form that take the form that is given. Take the 2x squared, divide by 2, minus 3x to divide by 2, a to divide by 2, which is x squared minus 3x over 2 equals 4, which is x squared minus 3 over 2 plus 1/2 of minus 3 over 2, which is 4 plus 1/2 minus 3 over 2. Okay. So you have minus that, plus now this one here is minus 3 over 4. You square that, which is 4 plus minus 3 over 4. You square this. Okay, this one is called the trinomial because of the 3 terms, and you can write minus 3 over 4. You square this because this you can write the x, you bring down the x, you bring down minus 3 over 4, you square everything. 4 plus, which is 9 out of 16. 9 out of 16. Which is x minus 3 over 4 squared, which is exactly 73 out of 16. Like so. Which means x minus 3 over 4 plus or minus the square root of 73 out of 16. So in the end then, which is x minus 3 over 4. Okay, because the square root removes the square. And then this becomes exactly the square root of 73 divided by the square root of 16. Right, and upon careful examination, this is x minus 3 over 4 is plus or minus square root of 73 out of 4. X, which is 3 over 4 plus or minus the square root of 73 out of 4. 3 plus or minus square root of 73 out of 4. Right, and you can write these as x equals 3 plus the square root of 73 out of 4, or x equals 3 minus the square root of 73 out of 4. X is approximately this, or x is approximately that. Using a calculator, we're able to see that in the 3 plus the square root of 73, it is 2.89. Okay, now 3 minus would be minus 1.39. And this is the answer. Obviously, I mean, we chose to write the answer to 2 decimal places here, but yeah, you can write it to 1 decimal place. But the examiner was not very specific there. But we're just highlighting the method of completing the square. We spent a bit of time a while ago with Peralero and the rest of the crew doing the method of completing the square, trying to explore that in a wide range of questions. This was a past exam question set in one of the schools, but it was a provincial examination in June. And this is what the kids at grade 11 had to do. This is what had to be done. So this is being recorded, so you're going to have a chance to watch this. And I'm going to send homeworks on the group. Please try the homeworks and do not sleep on them during the week. I'm going to send like hundreds of questions. I have tons of questions here as well that we're going to do. Next question. Right, so the next question is a very, very interesting one. We want to determine the values of x for which the following expressions are defined. Right, if you give it, for instance, x minus 3, for what values of x is this one defined? Anyone? For which values of x is that one defined? Who knows the answer? Anyone home? No one is there. Everybody is sleeping. Anybody home? Right, obviously this one is defined for, yeah? Somebody wants to talk? Tando,
Sir,
what do you think?
when x is less than 0.
Okay, that's fine. You're on point there, but when x minus 3 is greater or equal to 0, it just require that whatever is under the square root must be greater or equal to 0, because the square roots make sense. The square roots make, because we're looking for the values of x for which the following expression are defined. Okay, so in the real number system, this will be defined when x is 0 or more, when x minus 3 is 0 or more, and this will be defined when x is greater or equal to 3. You can bring the 3 to the other side, x greater or equal to 3. Where's the question? Where's the question? Okay, now the next thing we're going to look at is 1.2. 1.2, determine the values of x for which the following expression are defined. So if you're given 1 over x minus 3, for what values of x is this one defined? Anyone home? For what values of x is this one defined?
If x is equal to 3.
Okay, good. It is defined when the denominator is not 0, because we're dividing a number by an expression with an unknown placeholder x. So now it means that when x is not equal to 3, because when x is not equal to 3, then it means that we have that this expression itself is defined. So it is defined. Yeah, where's the question? Because when x equals 3, it is undefined, but we're looking for where it is defined. For which values of x will this expression be non-real? 1.2, for which values of x will k equals the square root of this be non-real? Anyone? Hello. Non-real. What would that be? So obviously we're looking at the case where k equals the square root of 3x minus 1 divided by x minus 1, and want it to be non-real. Non-real. For what values of x? For what values of x? Anyone? Anyone? People are sleeping. What do we do here? If we say non-real, we must solve for x when this is non-real. Non-real means what? No one knows. People have forgotten. People have forgotten. So, who is that? Tando. What's the answer?
Our base should not be equal to 0.
Please come again. I need to make sure I understand you.
So x should not be equal to 1.
X should not be equal to 1. Okay. Pehelelo, what do you think?
X 0, sir.
0. Okay, that's fine. Pehelelo, what do you think? Pehelelo, what do you think? Maybe I lost Pehelelo. Yeah, I lost Pehelelo. I don't know why. Right, so obviously, determine the values of x for which different expressions are defined. So I lost the others. Okay, anyway, non-real would be when this expression here is less than 0. It's when we have a negative under the square root, then it's non-real, because it's, if you take the square root of a negative number like 2 is said to be non-real. Okay, so that's something that is very important and that you need to take note of. All right, so which means that for now you have critical values. X equals 1/3, x equals 1. 3x minus 1, x minus 1. 1/3, 1, x. So when x is less than 1/3, maybe 0. 3 times 0 is 0 minus 1, it's a minus. 0 minus 1 is minus. You have 3 minus 1 here, x minus 1. So you divide the signs here to negative divided by negative, it's a plus. Between 1/3 and 1, what number can you pick there? Between 1/3 and 1, what number can you pick? This one is like a 0.3, 0.33 recurring. And then now this one is a 1. So close to 1, for instance, you can take like a 0.5. 0.5. So if you have a 0.5 here, which is 1/2, so you'd have here 3 times 1/2, which is 3/2. 1.5 minus 1, which is clearly a positive. And then now here you have the 1/2. 1/2 minus 1, it's clearly negative. Bigger than 1 is, you put here maybe 2. 3 times 2 minus 1 is a positive. 2 minus 1 is a positive. You divide these, you have a negative and you have a positive. So for which values of x will this one be non-real? So it will be non-real when this expression is negative and the negativity is between 1/3 and 1. So which means x is between 1/3 and 1. And therefore that becomes the answer to the question. So this is the answer to the question. The method we've used is called the sign table method. We used the sign table. Sign table. Okay, the next one is 1.3. Right, solve for x given this one. X plus 1, x minus 1/2 equals 0. What do you think of this one, Tando? What do you think of this one, Tando? Right, let's look at this
Sir,
one. Yes, too easy.
x is equal to -1 or x is equal to 1/2.
Well done. X equals -1 or X equals 1/2. Right, let's look at 1.3.2. Correct to two decimal places, you're given x squared plus x minus 1 equals 0. Minus b plus or minus the square root of b squared. Minus 4ac out of 2a. So you have -1 plus or minus the square root of the b squared, which is 1 squared minus 4a is that c. 2a. Over 2. So x is -1 minus the square root of 5 out of 2. Right, in which case, we have the answer to this one. We just need to now get the decimal equivalent of each of this. Okay, Berylina is back because I lost her. Right. We had lost you, Berylina, there. I was so sad. I was so worried because you got lost. But I'm happy that you're right back. Sometimes I think can always be a network thing. Don't know when the system gives you some errors and things, okay, and now seeing the errors that the system gives. Right, so but now we have the decimals of this, which means here x is approximately 0 decimal point 618. Okay, 2 decimal places, so 62. X approximately -1.62. Yeah. So now obviously we're dealing with the 2 decimal places here, so it is 6262 there. So correct to 2 decimal places. These obviously are the answers to the question. The answers to the question. Right. Who has a question on this one? Who is confused? Who has a contribution to make? Maybe you're seeing a mistake somewhere. You want us to rectify that. And you're like, hey, there must be a 5 there. There must be a 4. There must be this and that. Right. So you let us know. You let us know. Right. So we continue. We continue. Right. The next question is 1.3.3. I'm going to give you like a minute to try this one, both of you. 1.3.3. In 1.3.3, we have been given exactly x squared minus 2x plus 1 is less than or equal to 0. Right. You have 1 minute to do this one quickly, please. Both of you. Both of you. 1 minute to do this one. One minute to do this one. Right. Okay. So we continue. We continue. Let me know when you're done. X squared minus 2x plus 1 is less or equal to 0. What are the values of x? Who is done? If you're done, please let me know. If you're done, please let me know. If you're done, please talk to me. If you're done, please talk to me. If you're done, please talk to me.
Sir,
Yes.
which question? Yeah, it's 1.3, right?
Yeah, it's 1.3.3. Yeah. This one, x squared minus 2x plus 1 is less equal to 0, yeah?
Oh, 1.1.3.
Yeah, it's exactly this one. X squared minus 2x plus 1 is less equal to 0. That's the question you should do, which is exactly this one. Yeah. What's the answer? Yes. Pegalelo, how far? I lost her again. Never mind. Oh, I keep looking at student. Okay, what do you think yourself, Tando?
X is equal to 1.
X is equal to 1. Why is x equal to 1? How? What did you do?
Well, for 1.3.4.
Yeah, we're looking at 1.3.3.
Oh, sorry. 1.3.3.
Yes, this one. So you have x minus 1 minus 1. Like this, which is x minus 1 squared is less or equal to 0. So then in the end, what we're then getting is the following. What we're then getting is the following. So you'd have therefore that you have x minus 1 squared is less or equal to 0. So what is the solution to this, Tando? What is the solution to this?
Uh,
What is the solution to this?
so don't you use critical values?
Yes. What are the critical values here?
We have a negative 1.
There are two of them, x equal to 1, x equal to 1. And now the graph, associated parabola graph is going to be like this. But it's going to cut at exactly x equals 1. And therefore, for what values of x is this? Negative or 0, less or equal to 0? The answer is only x equal to 1. So this is the answer to the question. So this one is the answer to the question. This is the answer to the question. this becomes the answer to the question. Right. Any question on this one? We're doing 1.3.3, please. And we're doing this one here, this question. And we have solved it, and the answer is only x equal to 1. Who does not understand this? Where's the question on this one? To say, why is this, or where's the suggestion, a different view to this solution, in terms of how best this one can be solved? In terms of how best this can be solved. Right. So it's okay, and sort of understand this one. Right, the next question is 1.3.4. 1.3.4 is what we are doing right now, and it is x plus 3 times the square root of x minus 1 equals 1. Who can solve this one?
So first you must take the variable to the other side.
First,
And
you
you
must take the
square both
variable to the other side, and then we square both sides of this equation, and then it becomes minus x plus 1. Is it correct? And then we square both sides, correct? Okay. Yeah, so we're going to square both sides. Like this. And if you square, 3 squared is what? It's a 9.
9.
And you have, yeah, you have not x minus 1. And if you square this one, it becomes x squared minus 2x plus 1, which means therefore you have 9x minus 9, which is x squared minus 2x plus 1, which means this is x squared minus 11x plus 10 equals 0. And then this is, the factors are minus 10 minus 1 equals 0, which means x is 10 or x is 1. So which one is valid if you put there? Like if you put 1, minus 1 plus 1 is 0, 1 minus 1 is 0, so left equal to right. But if you put 10 here, it's going to be minus 10 plus 1, which is a minus 9, and therefore immediately that means that you have the square root equal to a negative, so this one is not applicable. So it is most certainly invalid. And we can then say that x is not 10, but x is 1. So we have that answer. Okay. Yeah. Any question? Any question? Where's the question? No question.
Yes.
Okay, we'll move on to the next one, 1.3.5. We need to solve for x given 3 to the power x plus 3 to the power x plus 3 to the power x equals 3 to the power 4. And we need to solve for x here. Okay, I'm giving you 1 minute to try this one. 1 minute to try this one. Let us know when you're done. One minute to try this one. Let us know when you're done. Okay. Who is done? Begin how far?
Sir,
Okay. Tondo is like he's done.
we since this wait,
Okay, what do you think?
we collect the like terms first.
We connect the like terms together. So what do we get if we connect the like terms?
X is equal to 3.
You're getting x equals 3. Okay, let us experiment and see. You're possibly on point. So obviously when we have three of these terms. We have 3 of the 3 to the power x, which is exactly 4 here. This is 3 to the power 1, which means you have 3 to the power x plus 1 is 3 to the 4th power. When the bases are the same, we equate the exponents and we have x plus 1 equals 4, 4 minus 1, which means x equals what? X equals 3. So indeed, x equals 3 there. Where's the question? Where's the different suggestion and input, a different view to this? Where's a different view to this? Where's a different view to this? Okay, in the absence of a question, we'll move on to the next thing. Right, next we're going to look at 1.4. So here in 1.4, we're looking at what we call the simultaneous. Simultaneous equations. Okay, let's make x a subject here. Making x a subject, you can move the x to the other side, leaving us with a 2y minus 6. So now you proceed to put 1 into 2. Put this equation into 2. So that we have 2y minus 6. You square this, 2x is 2y minus 6. Y equals 3y squared. Well, in the place of x, we put 2y minus 6. In the place of x, we put 2y minus 6. So there's x here, we put 2y minus 6. You square that. Plus 2 in the place of x, you also put 2y minus 6. You have y equals 3y squared. You square these. So if you square 2, you get a 4y squared. And then we have 2y times minus 6 times 2. 2y times minus 6 is minus 12. Times 2 is minus 24. Minus 24. You square minus 6, it becomes 36. 2 times 2y is a 4y times y, which is a 4y squared. 2 times minus 6 is minus 12. 12y, which is 3y squared. Which is 4 plus 4, which is exactly 8. Minus 3, which is 5y squared. Minus 24y minus 12 would give us minus 36y. And then you have a 36. This result is 0. Let's check this. Let us check this. Right, the factors of this are clearly 5y minus 6, y minus 6. Which means y is 6 out of 5. Or y is exactly 6. At this point, x is 2y minus 6. Y is 6 over 5 minus 6. Over 5 minus 6. Here we also have x for the other y. We have x. X is 2y minus 6. Y is also 6 here. 2 times 6 is 12 minus 6, 6. 12 over 5 minus 6. What is 12 minus 30? Minus 18. Right, so as a consequence then, we have y is 5 over, is 6 over 5. Y is minus 18 over 5. Y is 6, or x is 6. Okay, yeah. So we continue. We continue. Okay, we continue. Okay. Okay, we continue. Now we are actually looking at 2.1. And 2.1, we need to simplify that expression. So I'm giving you like a minute to simplify that expression, and then you let us know what you think. Giving you exactly like a minute to simplify that expression, and we continue and see what we can do. So simplify that expression. Simplify this one. We're going to simplify it quickly. We're looking at 2.1. We're looking at 2.1. Let us simplify this expression. Let us simplify this expression. Right. Who is here? Okay. Here is Tsenulo. Here is Tsenulo. I think that tomorrow must spend some time doing chemistry. Because, yeah, you guys on Monday are writing chemistry, the chemistry paper. So I think that we must spend some time doing chemistry because you guys are writing chemistry on what day? On Monday? Parallel, are you done? How far? 2.1, parallel, I'm giving that one to you.
Almost done, sir.
Okay, that's fine.
Almost done.
Okay. 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 Right, so he's done. Just interested in seeing how quickly you can. As I read, I'm thinking that tomorrow we can spend some time doing chemistry for the guys who are writing on chemistry on Monday, paper 2, science. Yeah. Like Samuel always just joined us, and I think that will be very ideal that we spend some time to discuss chemistry. To make sure that we are of great assistance at this point. To those who are ready. Right. Anyone who is done, please let me know. Because yeah, I just want us to, then we're gonna discuss it together. The aim is to give you a chance to try. The aim is to give you a chance to try. Right. Anyone home? Anyone home? Anyone home? Right. It's too difficult. Please, guys, finish up. I need to mark. We need to do something. We need to solve these together. We need to do corrections. We need to do the corrections. We need to do the corrections. It's like no one is finishing.
33x over 2.
You're getting 33x. Oh, please come again.
33x over 2.
Okay, thank you so much. Yeah, we're just doing the corrections now. So we have 3 to the x. Thanks so much, the Tsenulo. We have a chance to check. So we have 3 to the power x here, 4 times. So this one is 3 to the power x plus 2, but we can read it as 3 to the power x, 3 to the power 2 all over 3 to the power x, and this one is 3 to the power x, and this is 3 to the power 1. In the numerator, we take out the highest common factor, namely 3 to the power x. If you take out the highest common factor, namely 3 to the power x, we have the following. We have 3 minus, so we're going to factor out this one here. So we have the 3 here, we have 4 here, and then we have 3 squared, like so. And we continue to simplify the denominator of this expression. Divide everything by 3 to the power x, 1 minus 3. 3 to the power x cancels, giving us 3 minus 4 by 9, divided by minus 2. 3 minus 4 by 9 is a 36 over minus 2. 3 minus 36 is minus 33 over minus 2. What is minus 33 over minus 2? It's 16 and 1/2 as a mixed fraction. So that is the answer to the question over there. That is the answer to the question over there. And we are done with that part. And let us move on to the next question. Right, so the next question is tip and 1. We're looking at this one here, please. I need your maximum attention. We are doing June exam preparation. Even tomorrow, we shall go full swing. But yeah, I'm planning that tomorrow we spend a lot of time doing chemistry as well to just assist prepare for the chemistry exam on Monday for those who are going to be writing chemistry. Okay, this one. Now we need to simplify without the use of a calculator. We need to simplify this one. What is the first step? What do we do first? What do we do first? We need to simplify something that involves radicals. This is a grade 11 past exam paper, but yeah, what did the grade 11s in that year have to do in this exam? In particular, when they go to this question, what do they actually have to do? What do they have to do? Okay, y'all. So, anyone? We're doing 2.2.1. So what's the answer here? No one knows. No one knows. Hey, guys, who knows the answer? No one. No one. No one knows. No one knows. How far? Perenello. Perenello, how far? Tando. How far, Tando?
Sir,
How far?
we rationalize the denominator.
Rationalize the denominator.
I mean, we rationalize.
Okay, we rationalize. So yeah. We have the square root of 5, can write 2 plus the square root of 5. 10 over the square root of 5. Square root of 5, 2 plus the square root of 5. 2 minus the square root of 5. 2 minus the square root of 5. Over the square root of 5. So now, you multiply 2 times 2, which is a 4 minus 5. And then now, this is exactly, you have the minus here. 10 to the square root of 5, but you divide by minus 5 when you multiply the square root of 5 by minus square root of 5. At the top, you have 2 to the square root of 5. Minus 5, you divide everything by minus 1. Plus 2 to the square root of 5. Minus 2 to the square root of 5. Plus 5 plus 2 to the square root of 5. So this cancels and you have the square root of 5 here. And therefore, if you rationalize this, the answer becomes exactly the square root of 5. We rationalize the denominator in each case. But I understand that many would take to rationalize the denominator here, would just multiply by the square root of 5 over the square root of 5, which is as well a very correct approach. If you multiply by the square root of 5 over the square root of 5. So we have the answer. We have the answer. Okay, so yeah, that is then the answer there. And we move on to the next question and we solve a bit more things. For example, now we want to solve the big one. The big one. There's this giant one. This one. What is the answer to this giant one? I'm gonna send exercises on the group. You need to try them. You need to submit to me, and then I'm gonna mark them. We need to do this so that you can master these things. So that you can master these things. The next thing is to look at 2.2.2. No question here. Where's the question here? Where's a suggestion? Where's an input to make? Who thinks, okay, but there we can put like a billion, there we can put a trillion, there we can divide like this, there we can square both sides. Please let us know. Right. So we continue. We continue. Okay. And now, We look at 2.2.2. Right, I'm giving you like 1 minute to try 2.2.2. 1 minute to try 2.2.2. What is the answer to 2.2.2? What is the answer to 2.2.2? What is the answer to 2.2.2? All right, so you have been given the square. Pegelelo, how far? I need answers, guys. Please. I need to train you more. I want distinctions in mathematics from you guys, and this is very serious. It's a very serious matter. It might mean that this week you need to attend every day, like every day, if we want to get the distinctions we want. How far? Anyone? Sanulo, how far? Sanulo, how far?
Closer.
Yes, how far? Is it too easy? You need something more difficult. Parallel, how far? I'm checking on you guys because I want to know how far you are. I want to know what the answer is to this one. 2.2.2. What is the answer? How far? Anyone? How far? Anyone? Uh-huh. No one knows. Tando, how far?
A little bit far.
Okay. Pegelelo. How far, Pegelelo?
Yes, sir.
How far? Are you able to see, or maybe you can't see the question? Maybe you can't see the question. Tenulo, how far?
Coming, sir. Coming.
Okay. Right. This question was set for some kids and it was around 2018, in the year 2018. But yeah, I want to see what you guys can do now if the kids in 2018 got hundreds in this exam. I want to see what you guys are going to get. I want to see what you guys are going to get.
I might, I might,
Yes.
I'm not sure, sir, but
Mhm.
343, sir.
Well done. Well done. It's the correct answer. It's the correct answer, Tenulu. Very, very well done to you. And let us have a fair chance to discuss this. It can be done in many, many ways, but a lot of ways. But one of the methods we can use is to identify the fact that here we have 7 to the power 2008. So we can try to get 2008 from these things here. So if we do that, then we factor out 7 to the power 2008 from this. We are able to see, therefore, that we shall have the following. Right, so let me put the parentheses in order, putting what we call big ones on the outside and round ones on the inside. Okay, now here it's 2000 here, but we like 8, 11 minus 8. 11 minus 8 is 3. So it's going to be 7 to the power 3 because you add the powers. If you multiply, it's going to be 2008 plus 3, which is 11 minus. You pull out 2008 from this one, it becomes 1 plus the square root of 7, all divided by the square root of 7 to the power 2008. Like so. Upon careful examination, we're able to see that, okay, if you multiply out at the top here, you add the powers. Okay, each one is the square root, so you just add the powers of the terms under the square root. So you have 2008 plus 3, which is going to be 2011. And then here you have 2008 plus 1, which is 2009. This crosses that out. And then within the parentheses, we're left with this one, which is exactly the square root of 7 cubed minus the square root of 7. Okay, to the power 1 plus the square root of 7 squared, which is exactly the square root of 7 cubed. Right? Because this one and this one cancel out. We're able to see that these ones cancel out and we have this with square. If you square this square root, you get a 7 cubed, and this 7 cubed is a 3, 4, 3, something of that sort. And we're able to see, therefore, that this is the result to the question. This is the result to the question, and we are done. 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 Right. Well done to Senoluthe for getting that one right. Right. The next one is a very interesting question, but I mean, it's not the only way to do the question. You know, somebody can just say, because these things are divided like this, another student can say, okay, let's do this. You can just put the bracket here like this outside and put one big square root like this and divide these things here. This one divides this and divides that. So you have 7 to the power 2011, you divide by 7 to the power 2008. minus 7 to the power 2009 divided by 7 to the power 2008 plus the square root of 7. You square this. In which case, therefore, under the square root, you'd have, now you subtract the powers here because it's 2011 minus 2008, and then you'd have the square root of 7 cubed. Minus, here you have 2009, you subtract 2008, and then you just have a 1 plus the square root of 7, you square this, which is the square root of 7 cubed, and then you square this, and this becomes 7 cubed, which is 343. And that's the answer. Okay, now, obviously, I mean, there are many ways to kill a cat here. You can get 100% in this grade 11 exam. Okay, now let's look at 2.3 because I have a lot of grade 11 kids now. Tando in the Parallelo. Okay. Senator is grade 12. It's big. All right. He's the big boy in the house. Okay. Right. So, but now, okay, if you look at 2.3 now, I have these two. Right. You have 2 to the power x times 4 to the power y equals 1. And 4 to the power y to x equals 1 over 16. 1 over 16. So now let's solve this one. So these are like simultaneous equations. Let me give you like 1 minute. Quickly, give us the answer to this one. 1 minute. Let me know when you're done. These are simultaneous. They're there at grade 11, they're there at grade 12. Please show us what you are made of. Please show us what you are made of. Okay, sorry. I had lost Tando. These are simultaneous, guys. Just do this simultaneous. 2.3. Solve simultaneously for x and y given 2 to the power x times 4 to the power y equals 1 and 4 to the power y. All to the power x equals 1 over 16. Simultaneously solve this simultaneously quickly, give us the answer. Solve this simultaneous quickly and give us the answer. Solve this simultaneous quickly and give us the answer. What are you getting? Okay, 4 is 2 to the power 2, but there's a y equals 1. 4 is 2 to the power 2, and there is a yx, and this is 1 over 2 to the 4th power, 16. 2 to the power 2 yx equals 2 to the minus 4. 2 to the power x plus 2y, 2 to the 0. Okay, the bases are the same. If the bases are the same, you add the exponent, so you add x to 2y, and then the 1 is 2 to the power 0, and then x is minus 2y. Okay, guys, if you do not get these questions right, this week you are attending every day. By fire, by force. By fire, by force. We call this one equation 1, we call this one equation 2. Every day at 8 o'clock, you're going to attend. If you don't get these things right, because I want to get results from you, and this is very serious. Okay, now you're going to put 1 into 2, which is 2y. X is minus 2y equals minus 4. Which is minus 4. Y squared is minus 4. So you divide by minus 4, you divide by minus 4. This means that y squared is 1, and then you take the square root on the left. You put plus or minus, and you take the square root on the right, which means y is plus or minus 1. Okay, if y is plus or minus 1, then what is x? So for x, you're going to use these equations. So x is minus 2, and if you put the 1, you have minus 2. X is minus 2. If you put the minus 1, you have the 2. So you're going to, in principle, have x equals minus 2. So yeah, I can write them in order. So in principle, then you have the two values of y, like y is 1 or y is minus 1. X is minus 2 or x is 2. Like that. So this is the answer. This becomes the answer to the question. So who has a question here on this one? Who has a question here on this one here? If you have a question, please let us know. Let us know. Let us know. Question, just let us know. I have a question here, I have a question there, and we resolve it. We resolve it. So then we look at the next one. The next question is for us to attempt to simplify this. Right, we want to simplify 3 times the square root of 12 minus the square root of 75 without the use of a calculator. We need to simplify this. What is the simplification of this? What is the simplification of this? Who knows? What is the answer here and what do we do here? What do we do here? How to simplify this one? How do you simplify it? Hello, how far?
Square root 3, sir.
Square root of 3. What? Okay. Tanu, look at the square root of 3. Pehelelo is like, you wanted to say something?
No, nothing, sir.
Okay, thank you. That's fine. Right. So to simplify this is 3 or times 12 is 4 by 3. Okay, we choose the factors of 12, 4 by 3 because 4 is a perfect square. Okay, somebody can choose factors of 12 like 2 by 6, but they're all bad because none of the 6 or 2 is a perfect square. 75, we can choose 25 by 3. 3, then we have the square root of 4, square root of 3. Square root of 25, square root of 3. Square root of 4 is what? Is 2 square root of 3. 25 square root of 3. 3 by 2 is a 6. Ah, no. Square root of 25 is what? It's a 5. 25 here. Square root of 25 is a 5. What is 6 square root of 3 minus 5 square root of 3? It's the square root of 3. And that is the answer to this question. That is the answer to the question. That is the answer to the question. Okay. It's like if you have 6 apples minus 5 apples. From 6 apples, you remove, you minus 5 apples, you get 1 apple. Let's look at 2, 2, 1. 2.2.1. Without the use of a calculator, show that this is the case. So yeah, let's look at that one. Show that 2 to the power 2010. Two to the power 2010 plus 2 to the power 2012 is 5 times 2 to the power 2010. 2010 World Cup. Year of the World Cup. Okay. Year of the World Cup in South Africa. 2010. Now, you need to show that this is the case. Show this. You need to show this. But in showing this, they're saying without the use of a calculator, show that. So must not use a computer here or a calculator. I'm giving you 1 minute. Please show that and then let me know when you're done. 1 minute. How do you show this? How do you show this? 1 minute. How do you show this? If you can't get this week, you're attending every day until you write your June exam. Every night, 8 p.m., 8 p.m., 8 p.m., 8 p.m. You attend every day until you write your June exam. That's what is going to happen if you cannot get this one. Because it means that we're at war. You need to wrestle with these things until you master them. Let me know when you're done, please, with this one. How far? How far? How far? How far? How far?
It's true, sir.
It's true. What did you do, Tando?
I factored out, sir.
You factored out. So you took the left-hand side.
Due to the exponent at 2010.
Yes, well done. Thank you so much. Brilliant idea from Tando. So yeah. So now what you then do is you take the common factor. So obviously 2010 plus here, this one is 2 to the power 2010 times 2 to the power 2, because 2010 plus 2 is 2012. So what we then do is we can take out the 2010 as a common factor. And if we do that, we cross this one out. 2 to the power 2010 as a common factor. Then in the place of this one, left with 1. And here we'll have the 2 to the power 2. The left hand side. 2 to the power 2010. 1 plus 2 to the power 2 to the power 2 is what? It's a 4 plus 1, which is a 5. So the left hand side is 5 times 2 to the power 2010, and 5 times 10 to the power 2010 is actually the right hand side. So we've been able to prove this expression. We've been able to prove this expression. Next question. Hence do this. Hence now we need to do 2.2.2. We need to calculate this one. 2 to the power 2010 plus 2 to the power 2012 plus 10, all divided by 2 to the power 2009 plus 1. Okay, let's do this one now. Let us do this one. Let us do this one. Let us do this. And as soon as you're done, please let me know that, okay, sir, I am done. I am done. Let me know that I am done, you know. Right. So please let us know when you're done, please. Let us know when you're done. Right. Let us know when you're done. Who is done? Who has actually dealt with this? Who is through? Who is through? Who is through? Hey, you guys are not finishing. Why? We don't have the whole night to just do one question. We must do everything. Now we must go to geometry also. And then we must do analytical geometry. We must calculate distances. We must calculate gradients. You must...
Sir,
Yes. You must calculate angles. Yeah? What have you got, Tando? What is the answer to this?
I'm not sure, but I got 10.
Okay, you got 10. That's fine. We're going to check that together. Somebody got 10. Senula, what did you get?
Yes, I'm not answering.
Okay. Pekalelo, let me give you a chance to shine. I'm giving you a chance to shine. What did you get as the answer?
I'm too busy, sir.
Okay, that's fine. Guys, this week I'll have to make you guys to attend by fire, by force. Okay, this one is way too easy because what did the examiner say? They said what? Hands. What is the meaning of hands? What is the meaning of hands? If they say hands, why the word hands? Well, obviously because they...
Sir,
Yes?
we use hands when we're concluding.
Oh, okay. Yeah. We use hands when we're concluding, but now We use hence to say, in mathematics, when you say hence, we're saying using what you got from above, do this. Using a result from above, do this. So in mathematics, when they say hence, calculate the value of this, they are saying use your result from above. What is the result from above? The result from above is that 2 to the power 2010 plus 2 to the power 2012. It's 5 times that. So 2 to the power 2010 plus 2 to the power 2012. We already know that these two things, they are 5 to the power 2010 plus 10, all divided by 2 to the power 2009 plus 1. And then we are done like this. We're already done because here there's a common factor. The highest common factor we can see is a 5 here. And then if you pull out a 5, or you can, yeah, there are too many things you can do. We can be smarter. Because already we want 2009 from this 2010. 2009. So we can put 2 here times 2 to the power 1, 2 to the power 2009 plus 10, all divided by 2 to the power 2009 plus 1. What is 5 times 2? Is 10 to the power 2009 times 10 divided by divided by 2 to the power 2009 plus 1. So we can see therefore that 10, there's 10 here. So you can pull out this 10. Is one way to do this, but not the only way. So you have 2009 plus 1. This is Gauteng province June provincial examination, and it is here, this exam. So now at this point, this one cancels these, and the answer we're getting is what? Is 10. So in other words, the value of this thing here is 10. If you, obviously they're saying without the use of a calculator, so you must use your own reasoning here. You must use some skills. But the numbers they've put there are large. Sometimes if you go to the calculator, it's going to give you some error or something, you know, to signal that, it signals the fact that you don't need to use it. You don't need to use the calculator. You must just do the calculations by yourself. Let us look at 2.3.1, which is this one. So if you look at 2.3.1, we have x to the power minus 1 plus x to the power minus 1 plus y to the power minus 1. X to the power minus 1 plus y to the power minus 1. The question is saying simplify this. The question is saying simplify this. So let me give you a little bit of time to do this one, and then we're going to do corrections. Please try this right now. So you need to simplify this. Okay, you need to simplify this. So please try that and give us some feedback.
Yeah.
Who is done with the simplification of this one?
I'm done, sir.
Okay, what did you get, Tenilo? That was quick.
It's x. It's y plus x all over x plus x times y.
Well done. Yay. Yay. That is awesome. So here you have x and then you have 1 over y. So here you're going to take the LCD xy. So you have xy divided by x, which is y times 1. Y plus. Then you have xy, you divide by y, and then you get x. And then x times 1 is exactly x. So the answer is y plus x over x. That is the answer. So by this one, you get exactly y plus x all divided by xy. Another student can also write it as y, x plus y divided by xy. So you have those particular answers there. And here is another question that the examiner is asking. Hence, determine the sum of the reciprocals of two variables if their sum is equal to 10 and their product is equal to 20. I'm giving you 2 minutes to do 2.3.2, like 2 minutes, quickly. Anyone home? Home? Anyone home? Right, anyone home? We're doing this one. 2.3.2. Hence determine the sum. Hence determine the sum of the reciprocals of two variables if their sum is equal to 10 and their product is equal to 20. So right. If you're done, please let us know. If you can't see, maybe it's small. Maybe it's tiny. Right. Hence determine
Sir.
the sum. Yes.
I might be wrong, so I'm not sure, but
Yes.
I think it's 10 over 20. A half.
Well done. Excellent stuff.
Yeah.
It's like it's saying so much in strength today because they're saying hence determine the sum of the reciprocals. So the sum of the reciprocals is when we're adding the reciprocals, we're adding x to the power minus 1 plus y to the power minus 1. These are the reciprocals. We're adding them, we're getting this. But hence determine the sum of the reciprocals, and this is the sum of the reciprocals of the two variables if their sum is equal to 10. So in other words, if you add the two numbers, which are x and y, you get the sum is 10. And their product is 20. So their product, when you multiply the two numbers, what you get is what? Is 20. And then you simplify these, and this is 1 over 2. So hence determine the sum of the reciprocals, and the answer is the sum of the reciprocals is here's the sum of the reciprocals, and the answer we got is 1/2. We started with the sum of the reciprocals. Reciprocals means that x to the power minus 1 is the reciprocal. Okay, so yeah, so well done there. I can see that Tenolo is so much in spirit today. Right, it's so much energetic. Determine the nature of the roots of the following graphs. What is the nature of roots of this one? Anyone home? Nature of roots. Nature of roots. What nature of roots of this one? Anyone? Determine the nature of roots of the following graphs. What is the nature of roots here? If the graph is like this, what are the nature of roots? If the graph is like this, what are the nature of roots? You don't know. Pehanelo, I need to ask you because you're quiet a little bit. I need to give you a chance. Tando, what is the nature of roots of this?
Non-real.
Please come again.
Non-real.
Well done. Roots. Roots are non-real. Roots are non-real. If you don't want to say non-real, we say they're what? Imaginary. Discriminant is negative. Why? Why are the roots non-real, Tando? Another student might not understand why the roots are non-real when the graph is like this. How do you see?
And also, sir,
Yes?
the graph does not touch the x.
Yeah, the
axis.
graph does not touch the x-axis. It means that this graph does not have real roots. So, because if it had real roots, then it was gonna cut like this, either face up or down, you know? But if it is either that way or this way, it means that you have non-real roots. Because why non-real? Because it does not have the roots. What are the roots? The roots are the intercepts with the x-axis. Those are the roots. But here there are no roots. And here there are no roots. Okay, let's look at the next question. What about this one? Nature of roots of this one. Anyone? If the graph is like this, what are the roots here? What is the nature of the roots? Because you see, the question the examiner is determine the nature of the roots. Now, the nature of roots are very important. Okay, the graph is like this. Then what's the nature of roots here? What is the nature of roots? Yay! I'm just testing you guys because I want to know, I want to engage your minds so that you can learn. Because if I just keep giving the answers like that, you're going to sleep on the answers. Okay, the answer is this, then what? Then don't even understand that time. At that time, don't even understand what's happening. You just are receiving the answer and you're moving on. And that's not what we want. We're saying if the graph is like this, what are the nature of roots here?
They are real.
Yes, it means that the roots are real. Because these numbers that are here, -1, -2, -3, the examiner did not do. These numbers are real numbers. These numbers are real numbers. So we then say the roots are real, but obviously there's more we need to say. The roots are real, then what is next? But now there's only one intercept with the x-axis. This graph touches the x-axis only at one point. So the x-axis is like a tangent. It's like a tangent to the graph. So now every quadratic must have two roots. But now this one is like it's having only one intercept, one touch, one point at which it touches the x-axis. So we say that the roots are, we then say that roots are real and equal. There must be two, every quadratic is two. It means that they must be equal so that maybe it's equal to 2 equal to 2. Okay, so it might be coming from the quadratic that is, when the factors are done, you get this. And then you're getting x equals 2, x equals 2. Yeah. So it's having the two roots, but the roots are equal to each other. So this becomes sort of the answer. You know? This becomes sort of the answer. So the roots are there, but they are the same number if this number is 2 there. they're the same number. So in which case, therefore, the roots are real and equal, because 2 is equal to 2. Whatever the number is, it need not be 2, but it's just an example we give you. Okay, so we proceed to the next one. Okay, we are finishing our discussion, guys. Show that the roots of the equation are rational for all rational values of k. Guys, this is a Gauteng June examination provincial. Very likely you're gonna write a provincial. Okay. And obviously I need, sometimes you write a district, write district papers, you write, you know. Okay, do 3.2 is our last question. Show that the roots of the equation are rational for all rational values of k. Yeah. What do you do here? Anybody home? Anybody home? Okay, try it, please. I'll give you 1 minute. When you're done, let me know. Okay, when you're done, please let us know quickly. Be fast, guys. You don't have, these papers are like 2 hours in June because it's not the full syllabus.
Also, I
Yes?
think we should reorder
We
and
should yes, okay.
remove the brackets.
You can do that. So we can write this equation in standard form. What is the standard form in quadratic equation? How does the standard form look like? Something we call the standard form. What is the standard form? Is ax squared plus bx plus c equals what? Equals 0. So obviously at this point, this one here is already like kx squared, but now there is a 2k minus 1 x. Then you can just bring this one to the other side so that it becomes plus k minus 1. At this point, we're able to see that our a is k, our b is 2k minus 1, our c is k minus 1. Right? And then now with this, then we can be able to do our discriminant. Because our discriminant is what? It's exactly b squared minus 4a what? C. B is 2k minus 1. 4k. And then now you square everything here, which is 4k squared minus 4k plus 1. And then is 4k squared. Right, and then now we have 4k squared. This minus 4k cancels out. And this minus 4k squared plus 1. Hey, what is the answer to this? It's like it simplifies nicely. Minus 4k and 4k. 4k squared. And then it's like we're left with 1. How true is this? I need to check if there's no typo here. But it looks so true that the discriminant is only 1. Check it. Check it. Yes. And it's correct. And this one is a perfect square. And then we then say delta equals to 1 squared is a perfect square. The coefficients are rational. So the roots are rational. Right, the coefficients are rational, so the roots are rational. And that is the answer. And then we're done. Right, guys, it was awesome meeting you. I'm going to post a lot of questions on these things on the group. And yeah, because it's after 10 now. It's like 10:15. So I'm sure it's enough for you guys to chill and take a chill pill